Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Stephanie Glenn, your host. I am the Editorial Director at Data Science Central. I'd like to start our event off today by thanking Trifacta and Forrester for sponsoring today's event. Trifacta and Forrester are longtime supporters of the Data Science Central community, and we are honored to have them sponsoring our event today. Today's webinar is entitled Scale AI ML with Data Wrangling, featuring Forrester, to be presented by Trifacta and Forrester. Before we begin, I would like to briefly review the format of today's webinar. Today's event will be 1 hour long. We have two presenters who I'll introduce in just a minute. There will be a 10 to 15 minute Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. I'd also like to encourage our attendees to provide questions throughout the presentation. We will be reviewing and presenting them on your behalf during the Q&A portion of today's event. I'm very pleased to introduce today's speakers, Mike Gualtieri with Forrester and Mahesh Gandhe with Trifacta. Mike Gualtieri is VP and Principal Analyst at Forrester. His research focuses on software technologies, platforms, and practices that enable technology professionals to deliver digital transformations that lead to prescient digital experiences and breakthrough operational efficiency. His key technology coverage areas are AI, machine learning, deep learning, AI chips and systems, digital decisions, streaming analytics, prescriptive analytics, big data analytical platforms and tools, Hadoop, Spark, Flint, translytical databases, optimization, and emerging technologies that make software faster and smarter. Mike earned a BS in Computer Science and Management from Worcester Polytechnic Institute. Mahesh Gandhe leads the Platform Product Management initiatives at Trifacta, where he is responsible for RBAC, security metadata, API platform integrations, etc. He's a seasoned and hands-on product management professional with 18 years of experience of complete product lifecycle management. Prior to joining Trifacta, he worked at Unify Software on their catalog, prep, and governance platform. He started his career at IBM's T.J. Watson Research Center as an intern and then worked in IBM for 6 years before moving on to various startups. He holds an MS and CS degree from the University of Maryland, Baltimore County, in conjunction with MIT Sloan School of Business. Outside of work, he runs marathons and plays the Indian percussion instrument tabla. Thanks for being with us today, Mike and Mahesh. We're looking forward to your presentation. The machine learning race is upon us. Every organization is seeking to outpace their competition by leveraging AI ML to drive differentiation for their business. To win this race, companies are building up data science teams, investing in faster, more scalable cloud data platforms, and utilizing a growing variety of publicly available algorithms and ML toolkits. Yet, organizations ramping up these initiatives soon find that their ML processes are only useful if the data that is feeding them is clean and structured for the task at hand. They quickly learn that scaling machine learning is entirely dependent upon scaling data wrangling processes. Forrester VP and Principal Analyst Mike Gualtieri and Trifecta Head of Platform Product Management Mahesh Gandhe will cover organizational best practices for scaling data preparation in order to scale ML and AI initiatives. In today's latest Data Science Central webinar, you will learn common data prep bottlenecks in machine learning, such as data quality, feature engineering, and data blending, how data preparation platforms improve scale, collaboration, and automation of wrangling data for AI, organizational best practices and deployment scenarios for data preparation and machine learning in cloud, on-premises, and hybrid multi-cloud environments. Mike and Mahesh, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thank you, Stephanie. And hi, everyone. This is Mike Gualtieri from Forrester Research. Very happy to be here today to talk to you about some of the challenges of data wrangling and specifically in scaling data science. But before I do, I want to take a minute to talk to you about the context of this within artificial intelligence and especially Forrester's perspective. I mean, generally, we believe AI is a force for good. It's already being used in many different applications, and it's like any other technology, it's going to probably touch virtually every aspect of humanity in net positive ways. And we see enterprises adopting it more. You can see here in this chart that the number of companies saying no to AI is declining. The number of companies saying yes to AI is on the increase at just over 50%. Now, we believe that nearly every enterprise will use AI in the next 5 years. Many are actually using it without even knowing it, using certain machine learning models. And there's a lot of confusion. We recognize two types of AI, pure AI and pragmatic AI. And the easiest way to have a pragmatic conversation is to actually get pure AI out of the way, because that's not what we're talking about. Pure AI is more technologies that mimic the complete human intelligence, our ability to learn different things, generalized intelligence, to be creative. When we talk about AI, especially in the enterprise setting, that's not what we're talking about. So set pure AI aside. What we are talking about is pragmatic AI. It's narrower in scope in that it may be about one thing, a recommendation engine or predicting machine failure, or winning the game of Go or winning the game of Jeopardy, narrower in scope. But it often exceeds human intelligence. And that really translates to the AI technologies. And front and center here are the data technologies, machine learning and deep learning. So when we talk about artificial intelligence, and especially enterprise artificial intelligence, we're usually talking about the data technologies of machine learning and deep learning used to create predictive models. So within that context, pure AI is still far out. Pragmatic AI is what we're doing, and it's important to note that the huge prerequisite of machine learning and data and deep learning is data about the physical and digital world, and the use cases are many. AI is being used to augment human intelligence. It's certainly used for automation as well. It's used to acquire more intelligence about customers or about the environment. And it's sometimes used to create new products and business models. But it's all of those use cases that matter. And there are as many use cases as there are business processes and customer experiences. So ultimately, we believe that enterprises have thousands of use cases, at least a large enterprise. And it's all driven by machine learning. And, as you know, as data scientists, machine learning algorithms analyze data to create models that make predictions, make a decision, or identify some context. And it's a very simple process. Well, it's not so simple, but it's simple to explain. It analyzes the data, figure out what those input variables should be, and it will make a prediction. And this is sort of the life cycle that I know you're all familiar with, walking around this iterative cycle of developing models, getting the data to develop those models, putting them in production, and retraining on newer data, sort of a never-ending cycle. And that, and scaling this process, scaling machine learning, in other words, creating more models, maintaining those models in production, there's challenges. And what I want to talk to you about today is specifically the input and the huge prerequisite to all of this, which is a data challenge. So I put together 4 of our research-based best practices, challenges and best practices, and let's take a look at them now. So the first one is about this whole idea that it's like anything in computer science, and it's especially true when you're doing machine learning, is garbage in, garbage out. So that's, I guess that's the bad news, but the good news is that large organizations have dozens, hundreds of applications that generate valuable data. And this is, you have to think about this, or this is how we think about it, is that if you go to a large financial services, an insurance company, or any large company for that matter, you say, how many applications do you have? And if you go through HR and finance and all the different applications, whether they're cloud-based, whether they're software as a service, or their own applications, there's many of them, especially through acquisitions, but they all are an origination source for data. So there's a lot of sources, and when you start expanding use cases, you have to expand your access to that data. And, you know, fortunately, organizations' data is super rich, needed to scale machine learning to all of these use cases. I mean, if you think about it, though, a single use case may not be, it certainly has data challenges, it certainly has modeling challenges, it has its own challenges, but if it's an important use case, it may require data from a few sources. Maybe there's a data warehouse. It may require 3 sources to get a successful model. But once that model's in production, it may need more data to make it more accurate. And once you start multiplying those number of use cases, now you're multiplying the number of sources. So it can get pretty complicated. But the good news is that enterprises have that data, and it is the raw fuel. It is the prerequisite of machine learning. But all of those data silos, whether they're application database silos or even multiple data lake silos or data warehouse silos, whatever the case may be, they slow the data science process. So data scientists can barely start their project without having access to that data. So that's the first challenge to overcome. And we've heard many stories, and you've seen statistics about how much time data scientists spend on data prep or acquiring data. And, you know, part of the problem is they don't even have the chance to prep it because they have to beg to acquire that data in the first place. But we should also talk about another role, which is the business analyst, or sometimes known as the citizen data scientist. They also need access to that data to be successful either at machine learning or in collaborating with data scientists, because it's often business domain experts that provide hypotheses about what data might actually work for that particular model. So both of these roles are in desperate need of access to that. So, you know, our advice in this regard is just to remember and tell, you know, your business people that algorithms, they get all the press, but it's the data that leads to success, and enterprises have that data. So organizing a data engineering team to optimize the work of the data science teams is critical. And we have 3 options here. You know, option 1 is that a data engineering team delivers raw data. Some of these are grayed out, so you have to look very carefully on the data science side. There's a data engineering on the left, and on the right is data science. But on this side, data engineering's responsibility will be connecting to those sources and basically making the raw data available. And then the data scientist will pick up on the data prep, certainly the feature engineering and the modeling. And this option is best when enterprises have limited data engineering resources, or they may not even have a team to begin with at first. The second option is where you don't have data engineering. That's why it's crossed out. Again, I apologize for the you have to look on the right side at that data science. But if you have no data engineering team, which is often the case, but increasingly not the case, that means the data scientist teams are responsible for acquiring it, for creating that project data, doing the data prep. So they're going to need tools for that whole life cycle as well. And the final option is where data engineering teams and data science teams are working closely together. So on that side, the idea of prep is also taken on by the data engineering team. So this is where the data engineering team is more involved in whatever is being modeled, and they know a little bit more what has to be done on the prep side, and they provide on a silver platter what we've indicated here as the project data, right? And then the data scientist takes over on the feature engineering. So either of these three options are appropriate, but what you have to think about is what's the chain of tools that you use to empower both sides of that equation, both the data engineer and the data science. A lot of the data science platforms have what I call last mile tools, and sometimes those last mile tools are either not scalable or they're not flexible enough. So look at that relationship and the tool chain between data engineering and data scientists. The second one is about the challenge of rapid innovation. I mean, I guess that's good, right? We want rapid innovation in the number of frameworks, the number of algorithms, but it also, results in some problems because they have to support more than one tool. I haven't been to an organization that said we're just using this one modeling tool. They're using multiple, and generally that is because of the rapid innovation. Now at Forrester, we segment the market. So these are the tools that data science use. You call them data science platforms. We call them machine learning solutions, but we segment them in this way. Multimodal tools are, generally have very much like an IDE, like a modern development IDE. They have drag and drop pipelines. They may also have coding. They may have wizards to do some automation based. That's multimodal, and there's many tools out there that support this multimodal notion. And then there's the notebook-based. This has gained a lot of popularity lately, and that is usually based upon a notebook. Could be Jupyter, could be Zeppelin, could be a proprietary code notebook, but it's generally code first. RStudio, the developer is working in code, Python and R. They too have that same data need. And then there's automation vendors. They're more focused on automation. DataRobot, H2O.ai.data are an example of those vendors. Same data need exists. So we actually recommend through our research that most large enterprises will probably need all three of these. And we also have another perspective here, basically from our research, when we really dig down, well, why aren't data scientists, why are people saying data scientists are so expensive? A lot of that reason is because they're not as productive as they could be. They're spending too much time on wrangling data and not enough time on actually building those models. So with better tools, they can be more productive. And so too can those citizen data scientists for many particular use cases. So our advice in this area is that really look at those last mile data tools in the ML platforms, right? Data scientists see them there, and they might say, all right, well, this is how we do this. We use these tools. They may not be sufficient enough, and especially if you look at the notebook-based, which is probably the most growing use by data scientists is doing directly in Python. Ask them to show you your code. Let me see your Python code. Let me see your R code. They'll show you a few screens of code, and you say, all right, well, where are you actually training the model and evaluating it? Look at the end. It's probably 4 or 5 lines of code. What are those 3 or 4 other pages? Data prep. That's not very repeatable, not very traceable. So, our suggestion here is to look at common data wrangling tools regardless of the ML tool used. So it's a bit of a variation on the last word of advice, which is to use data wrangling tools that are sufficient for both roles. But in this case, it's making a clear delineation between when do you use those data tools in the last mile versus when do you use a common data wrangling tool in the tool chain. Third word of advice is the challenge of AI solutions themselves. And the problem with AI solutions is that they're like us. They're not perfect, right? These are probabilistic models that we create when we create a machine learning model. It's probabilistic. It's 89% right. It's 76% right. But that's actually in a point of time. When you actually deploy a model, that's when it's has maximum business value. You all know that the business value of those models, the performance of that model, the accuracy of that model can decay over time, leading to negative business value. So those models have to be monitored in performance. Unlike code, right, if you're just deploying code is deterministic. If you deploy that code, it's always going to run as written. Could be bugs, but it's going to run as written. ML models, they have to be retrained on newer data to stay fresh, and they're often remodeled as well. So think about that retraining process, because the retraining process has to use new data, but it may have to use reference data from when it was initially trained. So you need to keep that entire provenance, that lineage of the data in the data prep tool, because you're going to have to also use it to retrain. It's not just, data prep is not just exploratory is the point. And the data infrastructure that you used to train those models has to be available in perpetuity to train the models, right? So whatever infrastructure you needed to train that model, you put it in production, and then when you need to retrain it, you're going to still need that infrastructure. So there's a strain, it's not necessarily a strain, but you have to plan for more infrastructure, but you also have to plan to run that same data prep pipeline again. So, you know, our advice is keep those models fresh at scale with that new data, and you have to be able to repeat this cycle to retrain models. So data scientists who obtain data in a CSV file, or you know, by someone giving them some temporary access to the SQL statement and putting that in code is insufficient. It means that data wrangling process also has to be repeated on with that newer data. And so it's best to provide a data wrangling tool that can provide that discoverability, the explorability that data scientists need when they're working on a new project, but also can be automated for the retraining process. And, you know, because you still need that infrastructure in perpetuity on the retraining, cloud infrastructure is a great way to elastically provision this data. Look, we're talking about scaling AI here. So if you think about it in the context of, well, I'm building a model or two this year, yeah, I mean, you may not say, well, that's not that big a deal. But when you start to get to 50 models, 100 models, and certainly 1,000 models, or 1,000 use cases, it becomes a big issue and a hassle. And my fourth and final one is another challenge, which is it's a AI challenge, but it's also a data challenge, and that is opaque machine learning models make people nervous. They should make them nervous because they don't always know what data was used and what algorithms are used. And machine learning models are very powerful. You know, they can increase profitability, but they are about probabilities. And they're based upon correlation and not causation. So you have to be able to trace that data. And you have to make sure that those models are performing. And using digital decisioning platforms, the model might say, you know, make that $1 million loan, but you don't necessarily have to do it. But you have to also understand and explain that model. And data is often a proxy. It often expresses our human biases. And by biases, I mean all of these biases, right? These are shortcuts. These are actually a great thing about humans. We have all these shortcuts, but it's also negative as well. So to overcome this, data science teams have to be able to explain to a T what data was used and why, and they have to do it for their own integrity as well. So our recommendation is you have to trace those bits to business and don't deploy models that cannot be explained, especially in terms of the lineage of the data. So the data side of this, the data wrangling side of this, has to have data lineage and transformation and has to be completely transparent. And so that means when you bring in all data that's being used in the data science process has to be put through the data wrangling funnel. And so all roles should use that common data wrangling tool to record each and every data source and transformation that it takes so that's explainable and especially so it's repeatable. So those are our 4 challenges and advice when it comes to data wrangling. We see AI as one of the hottest topics at Forrester, and it's the fastest growing workload on the planet for a reason, is that there's so many use cases that have yet to be done, but to scale it is going to require scaling your data wrangling. So optimize the data wrangling tasks between data engineering, data scientists, use common tools for data wrangling. Even if all of your teams are using different ML tools, make sure you have a repeatable data wrangling process because you're going to need that to keep those models fresh. And use data wrangling also for explainability, to understand and to be able to explain to executives and regulators exactly how those models were built. So with that, I thank you, and I am now going to hand it over to Mahesh.
Great. Thanks, Mike, for sharing these great tips for scaling AI/ML practices. In the next 10-15 minutes, let me share with you information about Trifacta Data Wrangler. I'm sure you all must know this AI/ML pipeline. You first work on your raw data, then you prepare data, then you train your models, score it, and monitor it. But believe me, the majority of time is spent in data preparation. DJ Patil, the former chief data scientist of the US, stated that 80% of the work in any data project is in cleaning the data. 80% is a significant amount of time. But the good news is that if you use wrangling tools like Trifacta Data Wrangler, you can cut down this time significantly. In my presentation, you will see how Trifacta allows you to accelerate your data cleaning and feature engineering process by eliminating many of the steps that are just painful or tedious to accomplish using the code. And this will help you in scaling your AI/ML practices. So what are the common data preparation tasks you perform for building AI/ML models? Normalization. A key step in feature engineering is to normalize your features. A good heuristic is that you want as many of your features to look like symmetric Gaussians or uniform variables. Now, this requires you to discover data and understand its structure better. The next commonly used cleaning step is joins. As a part of the cleaning step is joins and unions. When you're designing a training data set for your model, you typically want to include a large number of features. An easy way to quickly add a large number of new features is by joining in a second data set that is related. Now, for doing these type of common data preparation tasks, you have a choice. Your data analyst, your data engineers, and data scientists can prepare data by writing code. This option can help you in getting started with your AI/ML journey. But this do-it-yourself option of writing scripts for data preparation is definitely not going to scale. The good news is that Trifacta can help here. Trifacta can help you for reducing time spent on preparing data by allowing you to perform various complex operations like joins, scaling, data cleansing in a single step. So how Trifacta helps? Trifacta generates a preview to show you the result of a data preparation task. It also regenerates profiles automatically. This enables you to quickly find out whether the particular operation is going to have the correct result instead of you writing code, running it, and then writing more code to profile the output. Using Trifacta Data Wrangler, your data engineers, your data scientists, and data analyst can cut down the data preparation time significantly and in turn scale your AI/ML operations. So let me share an example of one of our customers, Consensus. Consensus helps retailers prepare for innovation and change so that they can easily adapt and sell the next big thing in the market. Consensus wanted to build point-of-sales fraud detection model. As you all know, prediction accuracy of the fraud prediction model is very critical because one fraudulent sale wipes out the profit of 10. Their team was worried as they were having high numbers of false positives for fraud that was hurting their customer experience. Deploying models took weeks, and as a result, the data science team was not able to keep up with evolving fraud techniques. There were technical challenges too. Accessing, cleaning, and combining consensus data and third-party data in SQL was inadequate. It required too much support from data engineers. There were significant bottlenecks to evaluate new models for better prediction, because training one new model took 2 to 3 days and support of multiple data scientists. I'm sure you all must be familiar with these challenges. After deploying Trifacta, by leveraging Trifacta's machine learning-based suggestions for data cleaning and automated pipelines, Consensus reduced the time to deploy new models from 3 to 4 weeks to now under 8 hours. So more accurate models from data cleaned in Trifacta led to 24% improvement in fraud detection, 55% decrease in false positives, and 19% gain in revenue. And this is a significant improvement. Like Consensus, we have many more customers in different industry verticals from different countries in the world using Trifacta Data Wrangler for scaling their AI ML pipelines. Customers like SunTrust, Kaiser, and Singtel trust Trifacta for their data preparation needs for AI ML use cases. Now I'm going to show you a quick demo of the product. Let me share my screen here. So in this walkthrough, we are going to prepare a training data set to use in a model to predict the likelihood of loan defaults. Let's get started. I'm loading members' information from a CSV file. As I load this data, something that you may have noticed is that Trifacta shows you your data and automatically generates the profiles of every column. You can see these profiles at the top of each column. Our marketing team calls these column histograms. And you will probably jump in and say, well, some of these are just bar charts. Either way, these charts show the distribution of values in your column. So without needing to write separate code to profile all of your columns, you can immediately identify any field that requires cleaning. When you're working with this messy training data, you often encounter columns of different date formats. Fixing all these date formats can be time-consuming through code. I know I hate writing the regular expressions. Who likes it? For this particular model, we want to standardize the dates so that I can incorporate employment length as a feature. You can immediately see, just by eyeballing the data, that there is a couple of date formats in the emp_start_date column. I can generate a profile of all different formats in a column by opening the pattern details view. And let me show you how you do that. I'm selecting a column here, and I am seeing the different patterns, and I'm asking Trifacta to show me the details. So Trifacta is now telling me that inside date columns, these are the different column formats. Those were used inside your data. You can see that this view provides metadata about the components of each pattern, as well as the frequency of the patterns. Most frequent pattern appears to be the format with month, day, year. I want to make the less frequently occurring formats or the patterns conform to this particular format. You will see that the tool suggests a convert. I'm clicking here, and you will see some of the suggestions for conversion. And the tool is suggesting me that a convert pattern is providing me a convert pattern suggestion. These suggestions will take all of the messy date formats and convert them into a single pattern. And let me show you how. So I'm choosing this, and I'm suggesting to add it. And as you will see that all the dates are now formatted to this single format. I'm going back to my data set, and you will see the dates are now clean. So now you'll see that all the dates look uniform, right? So in pretty much any other tool, or even if you write code, doing these type of standardization requires first manually writing profiling rules to guess all the different patterns that are there in the data, then extracting each different pattern into a new column, writing more regular expressions to reformat every other pattern, and then combining all of those temporary columns back into a single column. This is extremely time-consuming, complex, and error-prone. And I have accomplished the same thing through 2 clicks. This is very powerful. Now let me show you how do you do joins in Trifecta. As you know, when you are redesigning or when you're designing a training data set for your model, you typically want to include a large number of features. An easy way to quickly add a large quantity of new features is by joining in a second related data set. Since joins are one of the most common actions when preparing data for AI ML, we have made the join operation quickly accessible from the toolbar at the top of the screen. I'll click on this button over here and then select the member loans dataset from the list. Notice now that Trifacta is doing something pretty cool. It has automatically identified the best join keys between the 2 data sets. I can also hover over the percentage match details to understand exactly why these keys were chosen. Trifacta actually collects column fingerprints on all the columns in your data sets and then figures out which columns have the most overlap. This join key inference can be a huge time saver if you are combining one of your internal data sets with an external reference source and don't know the key format upfront. So I'm going to choose a next here, and I'm going to choose all the columns after join. I don't want the duplicate keys here, so I'm going to deselect that. After reviewing, I'm going to add that to the recipe. So once I have completed my feature engineering process, I can click on the Run job to execute my recipe at scale using Spark. This will produce a final output data set that I can use to train my model. It's worth noting that there are over 100 functions available in Trifacta out of the box. This demo just scratched the surface of what you can accomplish using the tool. Hopefully, you are walking away after this demo with an understanding of some of the key benefits that include automatic previews of all transformations that you are performing and profiling that is incorporated directly into your transformation interface. I'm going to move back to my slides now. So let's review some of the additional key features of Trifacta. Trifacta Wrangler has a very intuitive visual interface. It is currently used by thousands of users. Trifacta has over the largest user community through our free and paid editions and Google Cloud Data Prep. It is the most complete data prep that is very easy to use. Trifacta Wrangler provides self-documenting lineage. Enterprise self-services practices are never complete without good governance practices. Trifacta automatically tracks lineages. It is currently integrated with Cloudera Navigator. It also provides comprehensive APIs for integrating with other lineage systems like Atlas and Manta. It also provides APIs for integrating with other tools required by IT for governance purposes. Trifacta provides instant previews for continuous validation. This enables you to validate your transformation logic while you are building it instead of having to do so when you run the job. And this speeds up the data cleansing process. Suggestions for data cleaning based on machine learning algorithms guide users and accelerate the prep process. And this cuts down the time it takes to prepare your data. Trifacta helps for not just building the transformations, but it also helps for getting them into production by automating data pipelines. It has integrated SDLC, that is software development life management tools for migrating code from dev to production environments, leading to faster deployments. In many cases, Trifacta results in shrinking 80% data preparation time to 8%, and that is 10 times improvement on most of the time-consuming part of the data projects, that is data cleaning. So let me share more information about Trifacta at this time. Trifacta is a widely used data preparation tool for AWS, Azure, and GCP. So how is Trifacta better, faster, and cheaper? A lot has to do with the architecture. The modern stack vendors themselves have also chosen Trifacta. There are many reasons for that, but a primary one is architecture. Trifacta understood this move to modern data platforms 7 years ago, and we built and architected the product to run natively within these platforms. For example, we fully leverage the compute engine for each platform. Literally, when we execute a job, these platforms are our engine, whether it is Google Dataflow, AWS EMR, Azure Databricks, or Cloudera Spark. In addition, we fully leverage the security paradigm of each of these platforms. For example, for Google, we are literally inside the Pantheon admin panel and leverage their IAM services. So this architecture is one of the main reasons Google decided to OEM Trifacta for their own cloud data preparation offering. Trifacta has been tried and tested by large enterprises. Enterprises like NASA, Bank of America, JP Morgan Chase, and GSK trust Trifacta for their data preparation needs. And you don't have to take our word for it. Various industry analysts have selected Trifacta as a leader in data preparation. Most recently, Trifacta was also recognized as a leader in self-service data preparation wave that was published by Forrester. Trifacta has 85 plus global partners, and that list includes technology partners like DataRobo and leading global SIs like Infosys. So what's next? How can you get started? We have various editions of our product. Trifacta Wrangler helps students and evaluators for trying out the product free. Trifacta Wrangler Pro is for individuals and teams with advanced needs. And Trifacta Enterprise is for complex, large-scale deployments. So you can go to our website and start wrangling. Feel free to reach out to us if you think we can help you in your data preparation needs. Thanks, everyone.
Oh, Mike and Mahesh, thanks for that excellent presentation. We'll get started with today's Q&A session, and I want to thank the audience for their participation. We've got a great many questions that have come in during the presentation, and we'll do our best to get through all of them in the time remaining. During this Q&A session, I'll leave up the screen with contact information for Mike and Mahesh. If you'd like to contact them for a copy of the slide deck following today's webinar. Let's get started. The first question that came in is for Mike. Out of the 3 models you explained, Mike, which model do you recommend for scaling AI ML operations?
Sure. Thanks, Stephanie, for the question. And just to confirm, you can hear me, right?
Yes.
Oh, good. Okay. Well, I mean, the best model is the one where the data engineers can also participate in the wrangling process. So if you remember, there was one step where the data engineers, their expertise in option A was they knew where all the bodies were buried in terms of data. They know how to acquire that data, and they would sort of dump it into some raw format or in its existing format somewhere. And then that's it. And then the data science team would go after that data. The second model was when you had no data engineers. That's not a good model for scaling because now your data science teams are burdened with all of the steps, including acquisition. And then the final model is where data engineers and data scientists work together. But the data engineer's role is a little bit more than just acquiring it. They're also doing some, let's call it pre-wrangling, because it's not to say they do all the wrangling, because data scientists want to do some last mile wrangling as well. So option C in the slides is the most desirable option for scale. Now, why I had those options was because maybe an organization isn't ready for that scale yet. But if you use the same data wrangling tools across that chain, if you start your data science teams off using that, essentially the data science team is performing those steps. But then as you grow and you scale, now you can add data engineers, and you can create that separation of concerns and tasks so that your data science teams can be highly leveraged.
Okay, thank you. There's obviously a lot to learn here. Would you mind clarifying how you are defining the role of data scientist versus data analyst versus data engineer?
Sure. Yeah, so maybe the definitions aren't quite settled in the industry, but here's my definition, and I think of it as the goal of these people, right? So the goal of a data scientist is to build a model, and that model is going to be used to make a decision. It might be used to be an insight, but their goal is to build a model. That's what they deliver. The data engineer goal, in my definition, is to deliver data. So to another role that is looking for insights, that is looking for modeling. So that means that the data analyst, their goal is to maybe do do advanced analytics. They may do some business intelligence that is not machine learning. They could do machine learning too. So the data analyst goal is to deliver insights. Data engineer models, which may have insights. The data engineer is to deliver the data to support those roles. Now, it's certainly true that data analysts and data scientists often have to play the role of data engineers, especially when they don't have data wrangling tools or they don't have a data engineer organization. So it's probably fair to say that many data scientists and data analysts probably perform a lot of data engineering techniques. The question is how far back in the chain do they perform, and what tools are they using? I would argue that data scientists who are working in R and Python, that's not a good way to do data engineering. Because it's not highly repeatable, it's not shareable in those tool chains. So I think that data analysts and data scientists, they need tools that specifically focus on that data side of things, especially when you're scaling, because now you want to collaborate among your growing team of colleagues, and you want to collaborate among all of the different roles.
All right, thanks for clearing that up for us. The next question that came in from the audience is, do you think data governance will impact scaling of AI/ML operations? If yes, what are the best practices?
Is that for me? This is Mike.
Mike?
Yep. Okay. So, so in part of what I talked about was elements of governance in my talk, right? So monitoring the models in production, right, because they can decay in production. So there's a discipline that we call model ops, sort of fashioned after DevOps. Some people actually talk about data ops as well. But whatever you call it, there's this process by which you get a trained model and you put it into production. And as I illustrated, it's unlike code where once you put it into production, it's good until there's a change. While in production, that model can decay. So one form of governance is monitoring the performance of that model and having a automated, recreatable process for retraining the model on newer data. So if you can't do that, and if you can't automate that and recreate that, you're not going to scale. But it's essential to the governance process to do that. Now, what we see in organizations now is they might write some scripts. It's one model. There's a lot of manual work done there. It's very similar to software engineering 15 years ago. You had the same issue of governance in software code. And it wasn't until DevOps became a discipline and kind of spurred an industry of DevOps tooling did we really get a handle on that. So that process of model ops is necessary to governance. The other governance process is more on the use of AI in general. We know that the model's performing based upon the data, but is it performing for our business? Is it ethically performing? Is it unbiased? So there's another element of governance that has to happen as well. So scaling that is also going to require a application development best practices, not just looking at the model, but looking at how that model is performing within an entire application, within a business process, and what are the implications. So there's almost like it's a whole other design and development group that isn't looking at the model per se, but is looking at how it impacts the larger business processes. And so that is also necessary to scale it as well.
Thanks, Mike. It makes perfect sense. Mike, I have another question for you, going back to the data engineering and data scientist question. Do you think data engineers and data scientists should use the same data wrangling tools? Would that help in scaling, or do you think AI, ML,
I think they should.
With different tools?
Yeah, I mean, yes. I mean, I categorically recommended that, and I did it for two reasons. So one reason is that if you look at a large enterprise or even a mid-sized enterprise that has data science teams, they're often using multiple tools for the modeling, right? So they may be using, like I said, there's some great Python library, and they want to do some modeling in Jupyter. But you may have a team that's using SAS to do risk models. So there's really good reasons why you're using different machine learning tools. But the common denominator to all of those is data, enterprise data, third-party data, external data in some cases, and how it's prepared, how it's acquired and prepared. It's acquisition side is very important there as well. So if you've got data science teams using the same data prep tool, instead of using the techniques or the, let's say, less sophisticated tools that they find in their machine learning platforms themselves, they're going to have more power. They're going to be able to do their own data engineering themselves in the absence of a data engineering team, and they're going to be able to and they're going to be able to use this across their whatever the machine learning tools they're using.
All right, thank you, Mike, for that clarification. Mahesh, are you still with us?
Yes.
Great. I have a couple of questions geared towards Trifacta. The first that came in is, does Trifacta provide any native integrations with AI ML tools, and can you share details about it?
Sure. So we have customers using us in conjunction with tools like DataRobo and also Domino Labs. So we have various customers who have built that integration themselves. The point I would like to make is that we have very extensible API frameworks. And using this API framework, you should be able to integrate Trifacta with any tool of your choice. So I think that the short answer is yes, it can be done, and we have various customers using us in conjunction with DataRobo and Domino Labs.
Perfect. Thanks, Mahesh. And another Trifacta question, does Trifacta support writing custom functions or UDFs, and how easy or difficult is it to create new functions in Trifacta?
Yeah, and I think this is one of the features of product as well. We do support writing your own custom functions, but I think before I explain how that works, as I said earlier, there are close to 100 plus functions we have already built, and they are available to our customers out of the box. So normally our customers don't need to write custom functions. Most commonly used functions are available. But having said that, we also have a very comprehensive UDF framework You could build your own functions, and our CSAs, our customer support team, can also help you for writing those functions.
Perfect. Thank you. Mahesh, another question that came in from the audience. If I try out Trifacta Wrangler, I end up loading data into Trifacta's cloud, which creates a security issue for our data. What is the way to deal with that?
No, that's a great question. I think it's best we can follow up after the webinar to understand which what exactly is your architecture, where are you getting data from, and where are you loading it? And we will be happy to help you if you reach out to us after this webinar.
All right. Thanks, Mahesh. Do you have any use cases on the finance function?
Oh, yeah, sure. So we have many customers, like large banks like JPMC, Bank of America, Morgan Stanley. They are currently using us for their data wrangling needs. And in addition to that, we have various customers, especially in the area of financial compliance and risk analysis. They use Trifacta for their data wrangling needs. So the answer is yes, and we have supported many customers, and we'll be happy to help you as well.
Perfect. Thank you, Mahesh. Another question for you, Mahesh. How Trifacta recognizes any variable that may need to be renamed for merging?
Yeah, I think this is, we are happy to, I think this is this question, we can share more details about the exact algorithms or how do we work on that. So I would recommend reaching out to us after the webinar, and we can go over those details.
Alrighty, I think we have time for one more question. Does Trifacta give out the corresponding code for a given list of transformations applied so that it can be tested on Jupyter Notebook, PyCharm by developers?
So at this time, what we do is we have our own sort of the native language that we write code into. So this is a functionality that is currently not available, but yeah, I think the way we work is we work with our customers extensively and bring this type of functionality back to the roadmap, right? So even though it is available now, and if this is something you need, we'll be happy to work with you and make that happen.
Oh, thanks, Mahesh. Thank you both, Mike and Mahesh. Great answers to some very good questions. For those of you that asked questions that weren't answered today, we will be sending all unanswered questions to Mike, Mahesh, and the Trifacta team so they can follow up with you after today's webinar. I have just a few quick announcements. Please mark your calendars for June the 18th, 2019, and our next DSC webinar, AI in Action, Real-Time Anomaly Detection. Also, today's taping will be available for on-demand viewing later today and can be found at the homepage of Data Science Central in the Webinar tab, located at the top of the page. Past webinars are available on demand at datasciencecentral.com. If you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our data science community. This brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Trifacta and Forrester for their sponsorship, as well as to our speakers today, Mike Gualtieri and Mahesh Gandhe, for their insight into today's topic. My name is Stephanie Glenn, and I'm very pleased to have been your host for today's event. I look forward to seeing you all again on June the 18th, 2019. Have a great day.